Okay, today we will talk about interference of light. Okay, but at first, look this. But at first, go to the physics lab. Okay, what happens if a light ray pass through flat? That's when light wave pass through slit. What happened? It given cone shape, okay? This curve, okay? And this curve called wave front, called wave front. Wave front is the surface of the wave, and all points and it have the same face, okay? That's curve called wave front, okay? Wave front is the surface of a wave, and all points have the same face, okay?
Please.
What's the meaning of
Okay.
have the same face?
It means they're in the same position, have the same velocity in the same direction.
Good. Okay, so all points around this curve or wavefront have the same position and direction and velocity, okay? And amplitude and frequency, okay? Okay.
Okay.
What about two waves? What about two waves? Look, that's two waves. What happened? What happened?
They push off each other, they repel off each other.
Okay. Now two waves combination together, okay? That's called light interference, okay? Okay, okay. What's the meaning of light interference? Light interference is the superposition or combination of two light waves or more having the same frequency and amplitude and same direction of propagation. Okay, two waves or more having same frequency, amplitude, and direction of propagation. Okay, it's superposition of two waves or more having same frequency and amplitude and direction. Okay, okay. To understand what's the meaning of light interference, okay, Thomas Young do an experiment. Okay, it's called double slit experiment for Young. Okay, It's used to study the interference in light and determine the wavelengths of monochromatic light. Monochromatic light, like only red light or blue light, monochromatic light, okay? And to determine the frequency of monochromatic light. So, Young experiment used to study interference in light and determine wavelengths of monochromatic light and determine frequency. Okay? Okay. Okay. In our share screen. Okay. That's Young experiment. Okay. Look, light ray is passed through slit and it's give cone shape and this curve called wavefront. All points around it have the same phase and same amplitude and same frequency. Okay? And this wavefront pass through two slits. Pass through two slits. Slit one, up is slit one and down slit two. Okay? So it gives two waves of the same wavefront, so they have same phase, same amplitude, same frequency. Okay? Okay? So this
Okay,
two waves called coherent sources. Called coherent sources. Okay? Coherent sources are sources have or emit the same waves. Okay? Waves have same frequency and same wavelengths and same phase. Okay? So what's meaning of wavefront? Jana? Jana?
Wavefront is the first one that passes through the one slit.
Okay. Wavefront is the curve, okay? Okay. That's a surface of wave and all points have the same phase. Okay. And coherent sources are sources have the same or emit the same waves, have the same amplitude and frequency and phase. Okay? So the light waves, okay, are combination, and as a result, we have on screen fringes, dark and black color, and bright, dark and bright. Okay. Okay. So a Young's experiment used to study interference in light and used to determine wavelengths and frequency. Okay? Okay. So, in Young experiment rule, okay, we could the distance between double slit D. Distance between double slit is D. And the distance between double slit and screen called R. Okay? And the distance between two successive fringes of the same kind, dark or bright, delta Y. Okay? So, to determine the wavelengths or fringes we used our rule, delta Y is equal wavelengths times R divided D, where delta Y is the spacing between two successive similar fringes, and R is the distance between two slits and the screen, and D is the distance between the two slits. Okay? And to determine wavelength from this relation, okay, crisscross delta Y times D is equal wavelength times R, so wavelength is equal delta Y D divided R. Okay? Okay. Yusuf?
Okay. Yeah.
Okay. To determine the wavelength of monochromatic light, use this rule. Okay? And to determine frequency, what I do, to determine frequency, we will do velocity of wave or velocity of light divided wavelength. Okay? And the interference fringes, dark or bright, become more clearly as, look, that's our rule. Delta Y is equal
Yeah.
wavelengths R divided D. Okay? So delta Y, distance between two successive fringes of the same kind, become clearly. Okay? امتى؟ When, look, delta Y is dark with wavelengths and dark with the distance between screen and double slit, and inverse to the distance between two slits. Okay? Look, that's two slits. Distance between them, D. And this screen of fringes. Okay? Distance between screen and slits, R. And delta Y, it's the distance between two successive frames. Okay? Okay. So delta Y is inversely proportional with the distance between slits. So interference fringes become more clearly as the distance between two slits decrease. Okay, because delta y is inversely proportional to z. Okay, and when the distance between screen and double slits increase, so delta y is direct proportional with r. And when using light of greater wavelengths, so delta y is directly proportional with wavelengths, and wavelength of red color is the maximum wavelength. Okay. Okay.
Okay.
Okay. Conditions produce constructive or destructive interference. Constructive interference is the bright fringes, and destructive is the dark fringes. Okay. Conditions to produce constructive or destructive or interference in general conditions is the two waves must have the same frequency and amplitude, must have frequency and amplitude. Okay, and the path difference between the two waves at a certain point must be constant. With time, we will take about this later. Okay, and two waves must have the same direction of propagation. Okay, so the first condition must have same amplitude and frequency and have the same direction of wave propagation, and the path of the path difference between the two waves at a certain point must be constant with time. Okay. Okay. A constructive wave or constructive interference. Okay.
Okay.
This happen when trough meet trough or crest meet crest. Look. In Young experiment, look. One wavelength or one crest meet other crest. Okay. That's constructive interference. Okay, like this. Look. One crest of second wave meet other crest in the first wave. Okay, what happened? Look, crest meet crest, so amplitude become more, and that give a bright fringe. Okay, and that's called constructive interference. Okay.
So they merge.
What you say?
So the two sound waves merge together.
I
Yeah.
can hear you.
when they pass each other, they merge for a second and split again?
Look, and with a young experiment, okay, we say that we have two waves, two light waves, okay? And waves consist of crest and trough, okay?
Yeah.
Okay. And the first source, our first slit and second slit, they emit waves, okay?
Okay.
So when they pass through or they travel, they maybe meet or they must meet, okay? So
Yeah.
maybe a crest of crest 1 met crest 2, or crest 2 met crest 2, okay?
Okay.
Okay, so when crest meet crest, that's called constructive interference. And that given right frame. And when trough meet trough, that's called also constructive interference.
Constructive.
And given right frame. But
Okay.
when crest meet trough, that's called destructive interference. And that given dark frame. Okay.
Okay.
Look, when crest meet trough, when crest meet trough, what happened? Look, what happened? They canceled each other. Okay. Okay, so the line is become straight at the moment. Become straight. So it's given dark frame. Okay.
Okay.
Okay. But when crest meet crest, look, amplitude is double.
Yeah.
Okay, so that given right frame.
Okay.
Okay. And this crest meet trough,
Yeah. They.
dark.
Yeah.
Okay.
Okay.
Okay. So constructive interference when crest meet crest or trough meet trough. Okay. And that's given bright frames. Okay. Okay. And the path difference. What's meaning of path difference? Path difference between two waves as delta is equal m wavelengths when m is 0 or 1 or 2 or 3. Okay, look, path difference, that's S1, slit 1, and slit 2. And this screen of slit. The center frame, screen or frames, the center frame is always right. Okay, and then dark frame. Okay, that's called first dark frame, and this called first dark frame. Okay, Then bright fringe and bright fringe also. So that's called first bright fringe, and this called first bright fringe. Okay. Okay. And then dark, second dark, and second dark, and second bright, okay? Okay. The first bright is always the center fringe is always bright, okay? Biggest difference, okay? That's the difference between light waves come from slit 1 and slit 2. Okay? Look, the path of light wave come from slit 1 to center. And this path of light wave come from slit 2. Okay? So they come from the slits to the same point. Okay? And the distance is equal. So this path is equal. Okay? And that's path of light wave come from slit 1. And this path of light ray come from slit 2. Okay? They aren't equal. Okay? One of them greater than other. So that's called path difference. Path difference is the difference between distance of path of light wave come from slit 1 and distance of path of light wave come from slit 2. Okay? Okay. In constructive interference is always crest meet crest or trough meet trough. Okay? Okay? That's always path difference is number of wave. Okay? Okay? I'm sorry.
Okay.
Look. That's path difference to bright. We talk about constructive, so we will take path to bright. Okay? We take the path to bright. So the first dark fringe path difference is one wavelength. Okay? So it's called first. Okay? And the path difference to bright or center fringe is 0. The distance is equal. And the path difference to a second bright fringe is 2 wavelengths. Okay? And the third bright fringe is 3. Okay? Okay? 0 of the center. And first bright best difference 1, and second bright best difference 2, and third 3, and fourth 4. Okay. So best difference in constructive interference is equal m times wavelength. M must be can be 0 at the center, or 1 of the first, and 2 in the second, and 3 in the third. Okay. And in destructive interference, that's happen when crest meet trough. Okay, when crest meet trough. Okay, so there is half wave. There is half wave. Okay, when crest meet trough, like when second crest meet second trough. Look كده, look. That's wave 1 and 2 wave. Okay. And the second that come from slit 1 and come from slit 2. Look, wave and second and third. Look, at this point, that's wave 2 and half. Wave 2, 3. Okay, look, this, the third crest meet the third trough. The third crest meets the third trough. So the distance 2 greater than 1 by half. Okay. Okay. Jana? فاهمة يا جنى؟
Yeah, okay.
Okay. Look, the third crest meets the third trough. Okay. So wave 2 greater than wave 1 by half wave. Okay. That's the bass difference. Okay. So, and destructive interference is a bass difference calculated by m plus half wavelengths. Okay, is always there half. Okay. Okay. So the bass difference to the first dark fringe is look in this. Look in our figure or this. That's the first dark. Okay. So the bass difference to the first dark is half, and to the second dark 1.5. Okay. Okay.
Okay.
Jana? Jana?
Yeah.
فاهمة ولا لا؟
Yeah, okay.
Okay. Okay. So the path difference in constructive interference is equal number times wavelengths. But in destructive, that's their half. Number and half. Okay? Okay. So what you can say as path difference to reach the first bright ring. First bright ring. خلينا متفقين ان الموضوع ده مش محتاج تدريب. فاهم؟ انت دلوقتي بتتخيل معايا المنظر، تمام، ومع التدريب ومع الحل ومع يعني التكرار الموضوع هيثبت في دماغك وهتبقى قادر تستوعبه. انما خلينا متفقين الحاجة اول ما تسمعها لأول مرة تبدأ دماغك ايه؟ بتجمع. فاحنا دلوقتي بنحاول نعمل التجميع دي سوا ونكرر اكتر من مرة علشان ايه؟ تقدر تستوعبها. اوكي؟ بس خلينا متفقين لحد دلوقتي مستوعب اللي بيحصل ولا لا؟ ها؟
Yeah.
مالكم يا شباب النهارده؟
لا معاك.
ها؟
مستوعبين.
مستوعبين جنى؟
أيوة
مستوعبة؟
أيوة.
طيب اوكي حلو قوي. حتى لو في مثلا نقطة تايهة من دماغك مع التكرار هنجمعها. فاهمة؟ احنا دلوقتي بناخد المعلومات، السيشن اللي جاية نعمل ايه زي كومبير كده او نجمعهم كلهم مع بعض بطريقة لطيفة. تمام؟ بس واحدة واحدة بناخد التدريج المعلومات ورا بعض وبعد كده نجمعهم في دماغنا بطريقة لطيفة. اوكي؟
Okay.
اوكي. So the best difference to reach first bright frame is
what?
what you say?
First, bright frame.
I couldn't hear you at all.
What happened? Okay. ده الترتيب في العموم للإيه للفرنكس. Center always bright and that first dark and that first bright. Okay. Best difference to reach first dark or the center is zero. Best difference zero. Best difference equal zero. And best difference to reach first dark 0.5 wavelengths. 0.5. And to reach first bright is wavelength 1. Okay? Okay?
Okay.
Now our time is finished. Okay? So see you in next session. Okay?
Okay. Bye.
Goodbye.